Hello everyone, Andrew here, and welcome to the second tutorial in our collaborative robot programming series. In this one, we are going to be teaching Tobor to move around pieces on a checkers board. So let's go ahead first and we will just run the game here real quick. Let's go ahead and get the machine ready to go. So first what we're going to need to do is home Z. So we're going to go ahead and home that. Then let's go ahead and home theta, which again is going to be the shoulder joint there. Let's go ahead and home phi. You can see now that our encoders and the machine both are reading the same values. So let's go ahead and let's get our program started here. So we created a little module here called checkers. Whoops. We created a little module here called checkers, and inside of checkers, we just have we actually have a game. So let's go ahead and take a look at that game. So you can see here that we have a list of moves that we're going to be going through. So let's go ahead and play this game. So our game here is going to be our game here. Let's create an object, game, checkers. We're going to be invoking the play game, and we are going to be playing checkers.game. So you can see here that we have a generator object of play game, and let's go ahead and feed that program now into Gerbil. Our game. So you can see that we're moving through here. Okay, and there we have it. So let's go ahead and disable these motors so that we can move the robot around, and let's go through and see how we actually program this robot. Okay, and we have our program here on the right, and we have our robot on the left. So let's go through and start looking at this. We'll just start from the top. So we have a few variables up here. These are basically, the Z pick is going to be how far we're going to be moving down our suction cup to go pick up a part. Z clear is where we're going to go when we either want to move a piece around or just move the arm around with no pieces. And the feed is how fast we're going to be moving around when we are making these moves. Bucket position, let's go ahead and drag the robot over to where the parts were dropped off. Let's move this so that we can see where the robot is. And you can see here the pieces were laid out someplace back here. We've defined this bucket position here at 68 and 99, and you can see here, I actually moved these a little bit, but 68 and 99 are pretty close to where these are. So you can see that when we're taking a piece off the board, we're dropping them in this place back here. which brings us to the board. And the board is actually where all the pieces are, or where the squares are on the board. So let's go ahead and move to the first position here. And you'll see here that we have 62 and 94. And, oops, I'm sorry. We have 84 and 117. And you can see that those numbers are really close to what we have here for the first position and where the robot is right now. And again, keep in mind that we don't have implicit inverse kinematics implemented yet. So we are changing P and T, representing theta and phi, as X and Y. So let's go ahead and see how we generated this board. Let's go ahead and pull up the little picture that we've got here. So you can see from this picture, we have columns that are A, B, C, and D. And we also have some rows here that are 1 through 8. And also keep in mind that you only ever use the black spots. So we are kind of keeping in mind that there are only one spot where we'll actually be moving pieces in each one of these columns. So A1 would be here, A2 is here, A3, and on. And these were defined. Let's go ahead back to our robot again. And we defined all of these with, let's go ahead and clear that. We defined all these with our command aggregator. So again, remember that we have this, and we also have our remote here that's linked up to this. So when we hit the green button, it's going to add a point where the robot is when we press the button. So what we did here is we have the first one, which is going to be A1. You can go ahead and press that. Move it to the second position. Again, button press. You can see here that the positions here are going to be roughly equivalent to where we did them before. So 117 and 84, 117 and 85, 133 and 61, 134 and 61. So the values that I'm putting here, I'm not making as much of an effort to actually get them centered as I did before. But again, you can go around and just do the entire board this way and mark off all of these pieces. So again, we have defined what our board is. You can go ahead also and copy this as a JSON list. So we can come here and just test, and you can copy it as a JSON list and then just paste this into some kind of program if that suits whatever kind of workflow you're doing. So let's go ahead and delete this. So we have defined all of the variables here. So let's go ahead and kind of dissect this and see how we're actually going to play our game. Again, we have our game defined here, and these are the moves that we're going to be going through to actually play this game. And this was some famous game that I found, and I don't really know how to play checkers very much, so this is what I found. We have this checkboard method, and you can go ahead and look at some of the other videos that we should have out by this point. But Gerbil is going to want to have generator objects and can run generator objects to create your program. So we have the points, or rather, we have the board that we defined above, which is all of these points here. And so we created a little generator that can yield some commands here. So what we're doing here is we're just going to like move through the entire. So let's go ahead and just run this checkboard program. Again, we're back in the robot GUI, and we are going to have to home our theta and phi. We can leave Z where it's at because we aren't actually going to be using it. Otherwise, we would have to home Z as well. So again, let's go ahead and run this. We have already imported our checkers module. Let's go ahead and create an object for Gerbil to run. So checkers dot checkboard. And you can see now that we have a generator object that is our checkboard program. So let's go ahead and pass that off to Gerbil. Gerbil.run, our generator here. And let's go ahead and let that go. So you can see that we have moved to the first point on the board. We are going through each of these. Let's go ahead and look at our program. See if we can fit all of this on the screen at the same time. So again, what we have here is we are going through for every point in the board. We are creating a move command. We are taking theta and phi. Again, we don't have inverse kinematics implicitly implemented yet, so we are changing those to x and y. This will be changed in the future. And we have our feed. So we're moving to each point, and then we're going to wait for 3 seconds. Move to the next point, and we go on and on and on until we hit all of the pieces on the board. So let's move this a little bit faster, and we'll be back in just a second. And there we have it. So you can see that we have all of the points of our board defined, and we'll use that to create our program. Okay, so let's dig a little deeper into our program. Again, we have our board laid out. We have the position of where we're going to drop off the pieces when we need to remove them from the board. We have the game that we're going to be playing. And let's go ahead and look at how we actually play this game. So we play game and we pass in the game. Again, this is just these strings down here to represent where we're going to pick a place from and where we're going to set it down. So we have a move like move from D3 to C4. And so what we're going to do is we're going to look at the first 2 characters, and we are going to be picking from the first 2 characters. So from this instance here, this would be from D3. So we're going to pick. So let's go ahead and look at our pick method, and we'll see what we have here. So the first thing that we're going to be doing is we're going to be creating a move command. So our command is move.linear, and we're going to be sending in also our feed rate. And we are going to also be saying, where are we going to move to? And for that, we are going to be getting a position. Again, this position in this first instance is going to be D3. So let's go ahead and look at this get position method that we have here. And this one, let's just go ahead and we can change this back to D3 so that we keep talking about the same thing. So we have a little list here so that we can get the index of the column that we're looking for. So D3, we know that we're in the 4th column. We're basically coming in here and we're saying, what column is it? We are going to look at what row it is. You can see here that we're actually subtracting 1, and I know that a lot of programmers like to think that you should start with 1, but when I'm looking at something in the real world, I like starting from 1. That's how I started counting, and really, you shouldn't be going through indexes when you're making things. You should use iterators. So again, starting from 0 isn't that important to me. We are going to get the board position here. We're going to use this column and row and figure out the actual index that we are going to pull this position out of our board list here. And then we are going to just do a little bit of polish. Again, change T and P to X and Y. This won't have to be done in the future, and we're going to go ahead and return that. And we're going to be updating this so that we have a full and valid move command. and then we are going to be yielding that to our robot. So just to start over again, we are picking a piece off the board here. So we are going to be moving to where we're above the piece. That's this first move. Now we need to move down to where we're going to actually pick up the piece from, again, at some feed rate. And here, now on this next line, we are going to be turning on the vacuum pump. So why don't we just take a second here and we will look at the program that we have. So again, we have this suck element here, and this suck element is a GUI checkbox. And let's go ahead and find this in our GUI here, and you can see that we have this GUI checkbox. And when we check it and uncheck it, our vacuum is going to turn on and off. Again, that's what we see here. We have our checkbox, and that's going to a pin that actually is the pin that turns on and off our vacuum pump. Additionally here, we have also tied this to our function button. So again, let's go ahead and press the function button, and you can see that when I push that button, the vacuum pump is also going to come on and off. Finally, the last way that we can interact with this is just in the REPL. So we have suck. We are going to find that we have our GUI checkbox. And we can pass that a Boolean, in which case we turn it on and off. So again, that is what's happening. In this line here, we are going to just evaluate this, and that's going to turn our vacuum on. So we've turned our vacuum on. We are going to wait or sleep for a half of a second to allow the vacuum to create a vacuum and pick up the part. And then we are going to do another linear move up to the Z clear and at the feed rate that we have defined for all of our moves. So again, really quick, just to recap, we're moving over the piece, we're moving down to the piece, we're turning on the vacuum, we're waiting for the vacuum to do its thing, and then we're moving back up again. So let's move on with our program. Again, we have now done this first line here. We've told the robot, hey, move over, go ahead and pick up that part. Now we're going to get to the second two characters. If there's an X, and you can see our program here again. If there's an X here, that means that we are going to be removing the piece from the board like you do with checkers. So a piece has just jumped another piece, and we need to remove it from the board. So if that's the case, we are going to remove. Now keep in mind that, just to go over it again, in this one, we've moved over the piece and we've picked it up. So right now, we have the part in the gripper, and we're right above where the piece was picked up from. So let's go ahead and look at this remove function here. Again, we are creating a move command. We're just going to fill it in with the generic stuff that we need, and then we are going to add in an X and a Y position that is our bucket. And again, that's defined up here. This is where our bucket is. So we're going to create a whole move command, and we are going to yield that back to the robot. So now the robot is going to move over the bucket. We are going to turn the suction off, and we're going to wait for a second and a half so the part can just fall off. So again, we've picked up a part. We have gotten rid of it if we want to. If we need to place the part, let's go ahead and look at that. So again, places here. Again, we're making a move command. We are getting the position, the actual XY coordinates based on our row and column. We're creating a whole move command. We're passing that back to the robot. We are going to now move back down again. So we have picked up a part. We have moved to where we want to move it. Now we're going to move it back down like we're placing it. We're going to turn the suction off. We're going to wait for the vacuum to clear. So we're going to wait for 3/4 of a second. And then now we have let go of the part, and we're going to move the robot gripper back up so that we can move around and go do something else. So you can see here, in the end, this program is actually very simple. We're just picking up, we're going to move, we're going to pick something up, we're going to move it to somewhere else, we're going to put it down. So that pretty much is the entire game. And yeah, generators, they take a little bit of getting used to, but they're really powerful, and they make things very easy to program. Okay, so let's go ahead and run our game again. Let's go back. We need to recreate our game object. So again, checkers.playgame and checkers.game is our game. Let's go ahead and verify that. We have our play game generator, which is going to be the program. And let's go ahead and have Gerbil run that. So gerbil.run our game. And before I press enter here, let's move this to the side so that we can see our game. And I will try to show off some of these moves as it's happening, as the game is playing. So let's go ahead and run this. So again, D3, column D, row 3, goes to C4. Next one here, A6 to A5, B3 to B4, next one is going to be we're going to be removing this part. Let's give some space over here. Again, we're making our jump. We're going to remove another part. C5, A, B, C. We're going to remove that part. Looks like it's going to be red's turn to move again. We're going to jump that black piece. We're going to remove the piece on D3. D8 to D7. B2 to B3. D7 to C6. C2 to D3. I believe that's this one here. Next move is B7. And our last move here. So again, we used our command aggregator. Let's go ahead and move this back. We used our command aggregator to create the points on our board. We use those points then to create a program that can take positions to move. We designed a game, and we ran it. So I hope this was helpful, and I'm really excited to see what you guys create. And let me know what you'd like to see next, some other kinds of programs, and we'll see you the next time. Thank you so much.